Good morning, my fellow scientists. It is Wednesday, July 12th, 2017, and I want to update you on the bag cell that I built yesterday. I used a polyacrylamide co-acrylic acid separator, which worked better than nothing at all, but not well. It turns out that minimal thickness of hydrogel just does not prevent self-discharge well enough. So you can see what the self-discharge curve looks like here. It took it about 3 minutes to fully discharge, and I don't see a good plateau indicating that there's not a whole lot of capacity there to begin with. Bottom line, separator's not great, volume of material is not great either. So how can we improve this? 1, we can use a thicker separator. 2, we can use more cathode material. The trick is, how do you fit that into the bag? So I gotta give that some thought, probably come up with some spacers and some thicker felt-like material to help keep everything separate, possibly impregnate that with the hydrogel as well. We'll have to play that by ear. In the meantime, I would like to address some really interesting comments I got about the bag cell. First of all, does the aluminum current collector degrade over time? And it doesn't seem to. I don't see any obvious pitting or degradation, and based on a little literature reading, that seems to be typical for modest pH, modest voltages. You're not going to see a whole lot of oxidation of the aluminum because of the passivating layer of aluminum oxide on the surface. Of course, that aluminum oxide also inhibits charge transfer, but it seems like it is good enough for both. It's thin enough to allow some charge transfer and thick enough to prevent the aluminum from degrading at 0.4 volts. That is all I'm actually applying to the thing. If we got up to 2, 3, 4 volts, yeah, it would absolutely cause problems, particularly at alkaline pHs where OH- can start to attack the aluminum oxide. But for now, it seems to be okay. There are some additives we could put in if it starts to be a problem based on this paper, where it discusses the notion of using some different additives like sulfate, nitrate to try to inhibit the degradation of aluminum oxide. So there are definitely options. For now, the biggest problem is self-discharge, and I think we can help that by just adding more of the gel and or supplementing with some cheaper gel. Maybe I'll add some of the agarose as well as the more expensive polymer. Tune in tomorrow. We'll get more into bag cell version 2.0, learn from our mistakes and try again. Eventually, I'd like to be able to produce a stack of bag cells into a series battery that will give a decent voltage with ridiculously cheap materials. So if you like that kind of thing, you like figuring out how to build DIY batteries, all iron chemistry, talking about science and progress, tune in Monday through Friday. We talk about all those things and more here in the Allen Lab.